Okay, so last one for today is 14.5. As I said, 14.6 is optional. It's there for you, but we won't cover it today. So now categorical data. So this is things like box plots, violin plots, strip plots, bar plots, count plots, point plots, etc. So there's a lot of cool built-in functions with Seaborn here as well. So and if you want, you can specify the style at the beginning right after you import Seaborn. Sometimes that's handy. We're going to load these 3 different data sets. These come built into Seaborn, so they're right accessible there. So a categorical scatter plot is called a strip plot. So this is a very basic way just to look at distributions. This is like you might see with a scatter plot, or excuse me, with the box plot, but even simpler. So here we can add a hue as well. So again, X is the day of the week, Y is the total bill, and then the hue, which is coloring, is whether it's lunch or dinner. So you can see there's a lot more dinner points on Saturday and Sunday than on Friday and especially Thursday. We can also instead of showing the day, we can show the size. This is the size of the party, and we can sort the values in that data based on size, so that when we plot it, we get things in the right order. And it's really easy to change the orientation, so we can make the total bill size on the x-axis and the day of the week on the y-axis. And again, we can have the same hue as a color of the data. So typically you might want to show this kind of data as a box plot. So there's a very handy built-in Seaborn function box plot where X is day, Y is total bill, and the hue is time. And you can even overlay these things. You can use both. You can have both the box plot and the strip plot or something similar. A violin plot is like a box plot, but it shows you the distribution. These are really nice, I think. So here you can see side by side, and again this is changing the orientation, but same idea. Side by side, these 2 different hues, and showing the distribution of the data. So if we want, we can change the parameters, since a violin plot is basically a kernel density estimate, and so it has all of the features of a kernel density estimate, so we can change how we render that. Another cool thing is you can do you can set split equals true, and instead of putting the 2 violin plots next to each other, if there's only 2 levels, it will make a split violin plot, which is a pretty nice way to see how the 2 distributions are different from each other. We can also do this inner equals stick, and this will show us the values. So this is a pretty cool way to see the individual values overlaid on top of the distribution. And you can do a strip plot overlaid on a violin plot, and the colors are a little hard to discern here. We can fix that, but the idea being that you can see both the distribution and the individual points overlaid. So we can look at, we can overlay some statistical estimation within categories. So we can generate a bar plot here, which will automatically have these distributions displayed. So again, we have an X and a Y, and then a data set, and then the hue, which is the subdivision. We can, this is now looking at, we've been looking at Titanic now, so we can see how many people are on each deck. We can pass a seaborne color palette. And we can change the orientation. Point plots are useful. This is to see differences in two distributions and showing us the average, the mean, and the distribution across categories. We can specify a list of markers and styles so that we can, and colors as well, so that we can more easily discern the different categories. And so we'll work our way down to here, but we can display multiple things on the same, multiple panels in the same plot. So here is just showing us a box plot or a violin plot or a count plot. We've seen these already. We can use this factor plot, which then allows us to show a different kind of plot. So here it's the same idea, but instead of using a bar plot, we're using this factor plot function and then just saying, okay, I want this to be this certain kind of bar plot. The advantage of this is that we can now take advantage of this multiple faceting of the data. So for example, we've now got day, total bill, those are X and Y. We've got a hue, which is smoker, and then we've got the time as our column. So we can start to tease out even more of the patterns in the data using the factor plot. So for example, we can have a four-paned plot here. Again, we have all the same options we had before with the size and the aspect ratio. And we can also combine some of these different features, so we can create a pair grid where we've got different X variables, different Y variables, and then on top of that pair grid object, we can create a violin plot with this certain color palette. So this is the reason that we're using these other functions that are different than there's sort of these core functions or basic functions, but then there's more generalizable options that, such as factor plot and pair grid, that allow us to get take advantage of these more smart grids that allow us to see multiple factors all at once. So we can really tunnel in and see a lot of different patterns in the data. As I said, I won't cover 14.6, but this is kind of building on some of this stuff where we have these data-aware grids and the kind of things you can do with that. We've seen some of that already, but this is kind of just building on that. So if this looks useful to you, I encourage you to dig into it. And in practice, we're gonna use Seaborn and Matplotlib both. They kind of work together, and for certain built-in functions, Seaborn's great, but Matplotlib gives you the ultimate control over everything. So this concludes Plotapalooza 2018. Thanks for coming, and see you guys next week.